Math Blast 5. I can solve word problems involving multiplicative comparisons. If 25 oranges are to be packed 5 to a bag, how many bags are needed? Write an equation with a symbol for the unknown number to represent the problem and solve for the unknown. I'm going to model this problem using a number bond. I start out with 25 oranges. I want to pack those 25 oranges into 5 per bag. So into groups of 5. And I'm going to keep doing that until I have used all 25 oranges. Skip counting, I can see I have 5, 10, 15, 20, 25 oranges now packed 5 to a bag. And I'll notice that there are 5 bags. I can represent this with an equation. 25 oranges divided or equally shared into groups of 5 is equal to B, the number of bags. 25 divided by 5 is equal to 5, and so 5 is what B represents. I can say 5 bags are needed. I can round to the nearest specified whole number. Round 26,354 to the nearest 100. Show your work. I'm going to use a vertical number line here. And I first want to identify the number at the bottom of my vertical number line. So using hundreds as my greatest place value, since hundreds is what I'm rounding to, I'm going to determine how many hundreds make up my number now. So I'll go all the way to the hundreds place in my number. 263 hundreds is the same thing as 26,300. If I add one more hundred for the top of my vertical number line, I would have 264 hundreds. That's 26,400. The midpoint, the number that lies right between our 26,300 and our 26,400, would be 26,350. Now I'll place my number 26,354 on the number line. I'll say it's about right here. And notice, since my number is above the midpoint, it's going to round up to 26,400. Anytime our number lies on or above the midpoint, it will round up. If it lies below the midpoint, it would round down. So I can say 26,354 is about 26,400. I can add and subtract multi-digit whole numbers. Find the sum of 378,268 and 415,543. A sum is the answer to an addition problem. So I'm going to add my two given numbers. I want to stack these numbers so that the place values are lined up. I'm going to use an algorithm here. And now I'm able to add like units. So I'll start with my ones place. 8 ones and 3 ones is 11 ones. 10 of those ones bundle and make a 10. 1 10, 6 tens, and 4 tens is 11 tens. We'll leave one of those tens here, and 10 of those tens will bundle and make 100. 100, 200s, and 500s is 8 hundreds. 8 goes in the hundreds place there. I'm in the thousands place now. I have 8 thousands and 5 thousands for 13 thousands. 10 of those thousands are going to bundle and make a 10,000. Now in my 10,000s column, I have 1, 7, and 1. That's 9 10,000s. And in my hundreds thousands column, I have a 3 and a 4 for 700,000s. So my sum, the answer to my addition problem, is 793,811. Find the difference between 264,053 and 72,821. The difference is the answer to a subtraction problem. So again, I am going to set this up for a standard algorithm. I want to line up my place values so that I am subtracting like units. Notice my 7 in this number here was in the 10,000s place. So I lined it up with the 6 that's in the 10,000s place of the other number, not the 2. That's a 100,000s digit. Now we can subtract like units starting with our ones place. 1 from 3 is 2 ones. 2 from 5 in the tens is 3 tens. 8 from 0 in the hundreds, I need to go and get some hundreds. I'm not starting with enough hundreds, so I'm going to go over to my thousands. I'm going to get one of the thousands, which allows for 3 thousands to stay there. The one that I get from there, I'm going to unbundle, and it will let 10 hundreds fall out. 10 hundreds minus 8 hundreds is 2 hundreds. Now I'm in the thousands place. I have 3 thousands minus 2 thousands, which leaves 1,000. In the 10,000s place, I'm starting with 6 10,000s, and I want to take 7 10,000s away. So here I'm going to need to go over to my 100,000s place. I'm going to get one of those 100,000s, which will leave one of the 100,000s there. The 100,000s that I'm getting, I'm going to unbundle, and it would let 10 10,000s fall out. But keep in mind, there were already 6 there, so that means there's 16 10,000s now that I'm starting with, and I want to take 7 of those 10,000s away. That leaves me with 9 10,000s. And 100,000 minus nothing is 1 left in the 100,000s. So the difference, the answer to my subtraction problem, is 191,232. I can model equivalent fractions. Model 1/2. Draw additional lines to create an equivalent fraction. What equivalent fraction did you create? So I'm going to model 1/2 by taking the whole and breaking it into 2 equal parts. So keep in mind the denominator in my fraction tells me how many equal parts are in the whole. I'm going to shade in one of those 2 parts. So now I have modeled 1/2. Now I'm going to draw additional lines. And so I am going to draw, let's say I'm going to draw 2 horizontal lines here. And so now you can see that my 1 piece has turned into 3 pieces, and my 2 in the whole has turned into 6 parts in the whole. So 1/2 is equal to 3/6. I can convert metric measurements, larger units to smaller units. Write the rule and complete the conversion table. The rule for converting meters to millimeters is times 1,000. We want to take our meters times 1,000, and that will equal the millimeters. So 2 meters times 1,000 is 2,000 millimeters. 5 meters times 1,000 is 5,000 millimeters. 11 meters times 1,000 is 11,000 millimeters. That's all for today, math friends.